Hello. I'll just show off my raycasting algorithm slash interactive game. I made it in as little lines as possible. So let's take a look at what I did here. So you can see I have movement. There's a wall right there. I can move and stuff comes closer. I'm able to move. I can move into another room. And you can see the back there. It's a little glitchy in the walls though. I'm sure it's just a simple condition I can check for. But see, once we're in the whoops. Once we're in the other room, it's okay. So you can see, you can go back, left, right. You can get really close. And even has the depth, so that changes the characters based on how far you are. So let's go ahead and I'll show you how I did it. Just go to Notepad++ here. Move this to the side. So here's my program here. This is the one I made as little lines as possible. It's 37 lines, and yeah, I'm sure I could make it less than this, but for right now, it still has like a coding convention here. So it has your end braces, and your keywords are still separated. So yeah, I'm sure this could be a 16-liner or even a one-liner if you just made the main and no spaces between no new lines. But so this is before I kind of gulfed it, and gulfing is making it as little lines as possible. So you see I have my condition here for the map, and the map it's just a sine wave. So you can see here I have a sine for X and Y, and that's the simplest kind of map generation you can get with the standard library. I'm sure you could use random or stuff like that, but right now this is the easiest, simplest way to get some kind of terrain generation or any kind of procedural generation. You just take sine and X and Y. So I also have it go in through another pass. So this is one frequency, and this is half its frequency. It just for more variation, or like an octave. In fact, I'm pretty sure it's like an octave. But you see, if it's greater than 0, which sine can go from -1 to 1. So if it's greater than 0, it'll be a solid. So you see right here, I have all the variables I really need: player X, player Y, and player angle. See here in main, I initialize them. I get okay, so I did cheat a little bit, and I'll get to how I kind of cheated in a bit. But here I take the console width and the console height. So I have a while loop, clear the console, and step is the ratio of the console width to 90 degrees. And that's your field of vision. So what I do from there is you iterate through your field of vision. That would be -45 degrees to 45 degrees. And then you step with inverse of your step, which step is going to be uninverted, but step is useful. Another part of the algorithm right here. You can invert it right here, or you can keep it not inverted. You can always just go back and forth as many times as you want. As many times as the floating point precision will let you. So from there, you take your angle, and you take the sine, and then you get your ray, and with that ray, it's gonna be in the correct direction. I think my microphone is messing up. Oh, I'm talking too loud. I should probably stand back. So you take your cast and your cast Y, and it's just at different angles. So as you know, cosine is 90 degrees out. So it's just going to be your y is just going to be your x and your y are going to be perpendicular to each other. And the negative here, it's just because you need your x and y to be at the correct direction to each other relative to the way you're doing the game math. Technically, you could just keep this cosine, but down here, it's just convention, you know? So you have your for loop, your test array, and this will just go and iterate and test if there is a solid there. It'll test for a wall. And you can see I have my character map from most solid to least solid. It doesn't look that great, but I've got to do as much as I can with the amount of space I have to work with. So basically you just test if solid, and if it is, you just do, you take the height of how far away it is. You can calculate how big you want your line to be vertically, because this is a renders vertically. So you take however much you want vertically, and you also take your height. So you just take those and you take your midpoint and then you subtract, and then you get your floor value, which is the space between the start of your line going up and down on your Y of the screen. And you just take that, and you can see here, or Y for drawing is offset by floor, and then your limit is going to be the height of the window subtracted by floor. And that'll give you correctly, well, probably not completely correct, but it'll be as close as possible. Because 90 degree, if you have a 9-degree FOV, the math is super simple. You don't need to do any more calculations. And truthfully, this is all you need. It's just, you take your vector, your point, and you subtract its distance, and then you divide by the distance multiplied by 2. And that is the simplest way you can go about it. It's an inverse square. Proportionally, it's a inverse square. So from there, you just write in the console. You just put a character right at theta plus 10 degrees. What was I doing there? Oh yeah. So for screen space, from your minimum x, that would be your horizontal pixels on your screen or your console. You have theta, and then you just, since theta is going to start, and that's your theta is another way of saying angle. So it starts at negative 45 degrees and goes to 45 degrees, and these are in radians. I should have probably said that earlier if you're not familiar, but sine and cosine need radians in C++. I'm sure you can convert, but seriously, if you don't know radians, you should learn it. So you just take theta, add your negative 45 degrees, or you add 45 degrees to counteract your negative 45 right here, and then you multiply by your step, which I said needed to be not inverted. So this can be a positive number most of the time, unless your console is less than 1.5708, which is half of pi, so 90 degrees, if I didn't say that already. You take your C width, that's going to be, what was it? Oh, it's, for my case, I usually do 100 by 100 console with raster font. That's what you saw in the beginning. Windows 8 is the only one with raster font. Anyway, this is going to be, around, maybe, well, it seems like 35. So 100 over, I had it right here. Never mind, not 35, 63. But it's going to be positive. And then when you invert it, whoops, let's go invert that. It's going to be a completely different number, but it's now from 0 to 1. Wait, no. No, whatever, you get the point. So basically you need to have it inverted, and then you just multiply it out, and it gives you the correct screen space from your lowest X to your highest X. And Y also the same. You get your X and your Y, and then you write your character, which is your test ray. From your characters, your array of characters, you just take your depth and okay, so this is a special case because my test ray can't be any bigger than the number of characters I have here. How many characters do I have? So here I have selected 10. So 10 characters, it can be no more than 10 for the depth. So okay, technically this is illegal. I should have done maybe another period, and that would have been okay. So once you've done that, you just supply your color and you break it because you're done with that loop. You need to go up and go to the next angle. Actually, that might be a way this could be simplified. Instead of going from -45. Oh wait, no. Never mind. I just forgot how it worked. So you take your C width and you take 90 degrees, and you're going to step by however much a single, and we actually calculated that, and that's going to be how many radians per section of the screen we iterate by. And you can see that. So actually this is a different version. I'm not going to bring my folder up because if I go to File Explorer, it's going to bring up others. Actually, no, we can just compile this. That's no problem. We can compile that right now. Never mind. Never mind. Actually, it's a very simple fix. Once we did that, you can see this is my debug version. It's much different than the one I'm actually golfing. And you can see here, I changed some things, so character's gonna be wrong because my other version uses Unicode or Windows. I think it's 1258. It's the Windows code page for Unicode characters, so it's gonna be wrong. So you can see here G. I never specified G or I or L as my characters, but you can see my debug version has a little map at the top, and it has my angle, my viewing angle too. So my debug version, my ungolf version is gonna be a little bit different. And so one problem with golfing is I couldn't do much with the screen. So usually, and I should probably get to that later. Okay, well, I'll put that aside for now, and I'll talk about the problem with golfing in a bit. So here I have my input. I just take a key without its modifier. Well, it doesn't count for shift because you can still press shift and it'll still be modified. But anyway, I need to take a key and unmodify it so I can switch it. And I can take A, D, S, W, and I just add to the player your inverted sine, or what did I just say? Inverted? Oh no, you just take your sine and cosine of your angle, and so A and D are your strafe. So you just take it and you move the player by 90 degrees. You get a right angle, and that's how much you want to move your player by. You can see it's also the same for Y movement. And that's all you gotta do for strafing. You just need to make sure you take the cosine, but you also subtract. And then for S and W, I'll just talk about W because S is just the same, it's just subtracted. So X plus the sine of player A multiplied by however much you want to move per time you click it. So per time you press the key. So it's going to be moving half a unit per time you press the key. So and then left and right are your angles. So right here I just did angle, and we move it by, what would that be? That would be 45. No. Let's see. So pi is 180 degrees, and then over 2 is gonna be 90. 45. So it's gonna be, oh geez, my mental math not great when recording. It's gonna be 23.5, I think. No, 22.5. 22.5 degrees per time you click the left arrow and right arrow. And then you press escape and it returns out of the function. Well, actually I didn't need this break here. Anyway, this is not the golf version, so that doesn't matter really. So what was I talking about with the wait, what was I saying? What was I saying about the screen? So yeah, so one problem is, you could see if I just build it again, is that what the hell was I saying? Oh, you can see the screen updates from left to right. That's because every character is being drawn at the same time. You could really see it. We could really see it now. I mean, to me, it looks normal, kind of, sort of. I'm used to it, but you could see definitely in the recording. I could see it's definitely going from left to right. So, yeah, one problem with golfing is I couldn't use, and usually I could actually show you, is I put it into a frame buffer and then I swap the buffer. Well, in this case, it's not swapping the buffer because you're just writing it once. But you know, normally it'd be called swapping the buffer. But you just write to a frame buffer and you write to the color buffer of all the characters and all the colors of the screen, and then you just push it to the screen every 33 milliseconds, every 30 FPS. But if you wanted small size, you don't want to really make a frame buffer. This is a good 48 characters here and 2 lines. So, oh, and also you need to specify how many characters there are. So that's a good 3 lines right there. You could just skip it and just use the right. So with that said, I just use the console right. But the thing is my library is kind of cheating in this use case, because my library, and if I can find it without opening a file viewer, that'd be nice. Let's see, what was it called again? Console. Do I have it open up? Oh, whoops. Do I have it open? I was just looking at it too. Ah, well, we can open it real fast. No problem. Console. Okay, so there's 2 files of this. It's console.h and console.windows.cpp. So these 2 libraries in total, and apparently I had console open. It's hard to look for stuff. There's so much stuff. I didn't want to have to look for it during the video. I don't want to open I don't want to edit the video. So you can see, so this is the implementation. So this is just console stuff. So in that program, all that's used, well, so we use these variables here for the state of the console, and we use the constructor and we don't necessarily need the destructor, but we need the constructor here. I don't use sleep because you don't need sleep, because it's pausing, it's stopping the thread every time you it waits for a character. It's blocking. That's what it's called, blocking. And so we use not this one of right, not this one of right. It's gonna be no, it's not that one either. But you can see for console width, it's a good, 114 characters. But when I write it out, it's just console width, and that's 26 characters. So I'm kind of cheating by using my own library here. So if I was doing it on Linux, it'd be much less characters, in fact. Because to do writing, you just do an escape sequence for ANSI C. No, it's not ANSI C, but it's called ANSI. It's an escape sequence, and that's all it is. You just enter in your coordinates of the character you want to edit, and you put the character you want to put in, and that's all you got to do on Linux. But on Windows, you gotta make a buffer, or you gotta open the system, the default buffer, your current buffer. But I didn't. Is my microphone clipping? That's just great. I probably should have. Well, I could probably edit that right now, but I need to keep it consistent. If you guys turn to volume down to watch this video, I didn't expect to start talking loud. Quite honestly, I was kind of whispering in the microphone to test it. So you can see console width and console height. It's right there, and it turns X and Y. But see, that's just so many characters, and you can't really do it much simpler than this in Windows. Sure, you could. No, you couldn't even do that, because this is sorry, too many characters. Why did they decide to make that so many characters long? I don't know, but that's what they did, and there's no way around that. You need to either specify, oh, this golfing thing uses this console library. Well, then you lose. That's why most of the stuff doesn't really involve too much complicated console stuff. It's usually going to be on Linux too. I suppose you could, in fact, just write and just do it sequentially and write all the characters to the screen, but that's, you don't know what your console height's going to be, but you can definitely specify when you're submitting it that your console should be 100 by 100 characters. But you can see, if I could find my right, here it is. Here, no, it's not it either. Here it is. That's the one I use. Not for that one specifically, but it's an example of it. So it first has to set the console color, and then it writes it to the screen. And you can see it should use this one. You can see it sets the cursor position as well. It does write console. So for console position, set console. Like, this is a ton of text, ton of program. But there's no way around this. So you can see set cursor position and set color, if it would set console color. So that's also more characters. If we could, so set cursor position is going to be just setting it. It's also a long Windows command or call there. There's no way around that. So for setting the color. Oh, and also reading the keys. Yes. Clearing the console too. Just too much. That's a good 453 characters. That'll set you real behind in a competition. So setting console color is going to test the color is active. It is, just return and set the active color and set the console type to distribute. Also needs to it needs to remap the colors too. So it needs to do that too. So if it's yellow and cyan, they need to be swapped. So also reading keys too, and that's a ton. It's much simpler, much shorter if you decide to use just Getch. Not even Getch. Getch is end curses, which I don't know if that's cheating or not, because if you use end curses, I guess, system libraries, but, end curses is installed by every installation nowadays, but is it really golfing? I don't know. You can see just to read keys and to do even the simplest, maybe STDC into a character, you need to press enter. That's no good if you want to make an interactive game. You don't want to keep pressing enter, but that's a good 869 characters. That's as long as the one I golfed. Look at this. 814. Okay, but there is debug information here, so every time I press a key, it's gonna have to. It prints debug information, and okay, it's STD bit set. So yeah. It's probably shorter than this, but it's just as long. It's just as long-winded. But you can see here's my extreme golfed one. So you'd see start with main, get your console width, console height, while loop, curly console. Now that stuff you just got to do, unless you did it right and so this does iterate through everything. So in fact, you could probably, well, no. If you wanted to remove the call in general, you could just swap the line around and do another line around here and replace the console clear, but there's no point. You're already using the library anyway, you might as well just use console clear. So same thing, but what I did, it's very important, is I dropped precision. So you can see here, I rounded it to -79. It doesn't really change it that much, but I'm dropping precision here. So you can see I removed this whole step variable here, and I just replaced it with the direct calculation. That's 1 over your width over 90 degrees. So also the same, you just iterate. In fact, this could be improved too, I bet. In fact, I could improve it right now. You can see how TR is used here. Well, what you do is you just, since it's already written here. Oh, this might actually not be that great, because this would work if it was an increment, and you could see I did that somewhere around here. I'm pretty sure I did. Yeah, right here. So you can see a simple increment, a post increment. That means it's calculated after it's the variables used. That's not the same if I wanted to do this. I suppose I could rewrite it to go from maybe 0 to 100. And that might actually work. And I could just iterate here. But I don't see the point in doing that. You'd save maybe a character if you're lucky. But you can see it's the same stuff, clockwise, not clockwise, console width, but you can see I used, and you just put a string here, and that's a pretty cool feature. You can put just a string there, and then you can what would it be? You can index that string. You can index a character in that string just with some simple index, and then that console color, it's just the number 4. And you can see here I did that. Is solid. It's this whole thing right here. It's just over 2. It's greater than 0. Oh, the bad part is for this you actually need to convert it. You need to cast it to an integer, because otherwise it's gonna make a rounded map instead of sharp blocks, which are better look at, I'm sure. But you could also just play around with, I'm sure. So you see floor, it's a very short calculation. And I'm sure you can golf this even more, but it's not that, don't need to. But you can see this is a total of 37 lines. And in fact, I can show you right now. Let's compile it. Well, I changed the build file just a little bit. In fact, I'm going to change it back because I don't need it. You can see I'm compiling with O2 as well, and oh well, that's great. Let's see if we, oh, there we go. It's just acting a little funny. Did I change anything? Don't think I did, yeah. I'll just revert my changes. I don't know why I did anything, but see? Same deal. Oh, well, it's, of course, a little buggy. But it's the same deal. Same deal as the other one, but it's just super simple. I mean, for this display, just a raycast, it's not even visible. You can't even see it. It's just that small. I mean, it's so small that it's right. It can fit right in this line here. That's where the display, the raycasting really is. It's right here. You can see. You take your sign, and so that's for the map itself. But what's really important here is you're taking the sign of, well, I forgot what this is. So that's a player angle plus theta, and that's it. That's your whole raycast. Well, of course, you're gonna have your current depth, which you're looking at right now. So you just multiply that by the output of sine. And that's it. That's your whole raycast algorithm, and you can do some pretty crazy stuff. And I think it's just so awesome. You can do it with just such little amount of. Well, I shouldn't even say, because sine, that's a pretty in-depth algorithm, but you can make a lookup table for it. You can make a pretty involved game with as short as possible. It's pretty crazy. Now, of course, if you wanted to do something with true 3D graphics, oh yeah, I'm sure it'd be a little bit more lines than this. And if you wanted to have a proper projection matrix, proper, if you wanted to look like Minecraft with all its 3D stuff, or just a regular old 3D game with triangles, it's an important bit, triangles, you do need to use, we got to sort the triangles if you want it to make it look okay. You don't necessarily need to specify a camera or anything, but you need to have the triangle. You need to store the triangle data. I don't know how easy that is to generate with a sine wave. I'm sure you could do it. In fact, I've kind of done that before with terrain. You can make terrain with just triangles, but I mean, you gotta store the triangles. You gotta sort them. They require a lot more finesse than just taking a sine and then taking a raycast. That's just as simplest as it gets. I'm really intrigued by these demo scenes, and I know this is turning into a long video, and it says, what? There's no way this is 34 minutes already. I don't leave that counter there. What a long-winded video. But, well, I guess if it's already this long, I might as well just keep going. So, you can see it's X def, and I think I already covered that. But that's it for proper projection, and you can just do a raster. In fact, it's called a raster. A rastering, rendering. You render the triangles. That's a raster. You go from top to bottom. Well, no, actually not necessarily, but you just take the triangle and you just use this algorithm is called projection matrix. It's not necessarily a matrix in this case. It's a one-line thing, but it is a projection matrix. You don't want... I could, implement a matrix, but in this case it's just this. That's all a matrix is. It's an equation. That's all this. That's all it is to it. It's so simple, but it looks like it's so complex. And truly, if you look into the demo scene, you can do some pretty crazy stuff. So the problem is this is actually very maybe not too demanding on the CPU, but if you wanted to make it have good assets and you want it to look okay, not buggy, not graphically glitchy or anything, it's gonna take a little bit more lines than this. And this is very CPU intensive. It's hitting that CPU. It's asking for so much of that CPU. And that's a problem if you make it so small, you gotta use a bit more CPU. If you take a look at Krieger, it's a game that uses only procedurally generated graphics. And to load the game, it takes forever because you're generating all the graphics at once. But the game is only 50, maybe 80 kilobytes, I think it was. That's truly impressive, but you got to generate everything as you go. You need to have all the 3D rendering. You need to do that. You need to either expand your lines. You need to make stuff abstract, and you need to do some other things. But if you just compress it down, you can really make it really compact, but it'll take a hit on that CPU. Anyway, I think I'm done rambling. I can't believe it's a 37-minute video. It just feels like it's been nothing. Anyway, have a great day.